Hello, my name is Christopher Flores, and this is my proficiency on primer design. The purpose of primer design is to create short, specific sequences of nucleotides that can selectively bind to a particular target DNA or RNA sequence. It is a critical step in many molecular biology applications as it allows researchers to generate accurate and specific results by ensuring that the primers only bind to the intended target sequence. The way that we design primers is that we put it into the software, Primer 3 Web, and then we paste our sequence, like the ones that we edited on our edit and sequence video, and we put them in there. In this area, we can change how long we want our product to be. In the place where it says product size ranges, I have it from 600 to 650. That means it'll give me a 600 base pair product. If I want a 700 base pair product, in product size ranges, I have to put 700 to 750 or around that range. And if I wanted an 800 product, I have to put like 800 to 850. And then after doing this, then we can select the button, pick primers, and then it will take us to the next part where we're gonna see the products and their different temperatures, how many base pairs long there are, and also their GC content percentage, which we can see from here that we are setting it that the minimum is 30 and the maximum is 70, with the optimum being 50. And in the base pairs, how many base pairs long, we're saying that the minimum is 18, the optimum is 20, and the max is 23. Yes, and I will continue explaining how to pick the right primer, like the primer that looks the best, in the next part. After you press the button to pick the button, pick primers, and then you get to this point. I'm gonna be using my 600 base pair primer to explain what we have to be looking for to find the best primer to use. And there's 3 things that we have to look in all of these options to see which was the best to use. So we basically have to see which one is closest to having all these 3 characteristics that makes it the best primer to use. First, it has to be 18 to 20 base pairs long. The GC content has to be approximately 50%. And the melting temperature has to be the annealing temperature, so the temperatures have to be equal. So you basically have to see which one of these options that you gets closest to these characteristics that you want. In this case, I would say I used the first one because it has a GC percent content of 55 to 50. The temperatures, which is the third column, look similar, and then we have a base pair length of 20 for both, and then it's a 602 base pairs long primer, and that seems like the best to me. I will be showing how the primers actually looked in the 16S RNA gene. I will be using the 600 primer I chose to make, in which we can see that it starts in the forward direction at 391 and in the reverse direction at 992, and the product size is 602 base pairs. This is how they would look in the 16S RNA gene. The 391 forward, you can see it there with the red arrow, and the 992 reverse, you can see it there with the green arrow. Thank you for watching. This is my proficiency on primer design.